Hello everybody, in this video I will show you how to generate a trajectory between two conformations of a molecule, and we will use minimal action path method. We will use minimal action path server for this purpose. We have to go to dynstr.pasteur.fr/servers address using your favorite browser, and then in the main screen you will see two options, and we will select MinActionPath 2. When you open here, basically you have recommended task title and email address, but there are two important files that are completely necessary. The first one is an initial state and the second one is the final state. We are giving these two states and we generate a minimal action path, a trajectory of minimal action path between these two states. And the first file is Zika virus obtained at pH 5. And the second file is Zika virus obtained at pH 8. Now I will say Zika test as name, and here you can write your email address. It's optional. When we go to the bottom of the page, we just say submit using default parameters. The files are big. We are modeling trajectory between two conformations of a virus, basically. So the job seems to be running. It will take some time to process the job to produce the trajectory between two conformations of Zika virus. When the job is finished, this screen will be updated. Now our results are ready. We can click here to see our results. We will encounter a page where we see a movie player. It takes some time to load the results because this is a very big file. This is a gigantic file, in fact. And after a while, within 20 seconds, you will see that your whole trajectory is loaded up and in front of you. Now our results are loaded to the movie player. Movie player we can play here. We can see the whole trajectory by clicking on play button. You can see that it shows a kind of breathing motion for this trajectory, and we can stop at any moment. We can take a snapshot of any frame and we can save it. We can make the screen full screen. We can load the visualization in full screen. That's also possible. Moreover, this is not a static movie player. We can rotate the molecule to see details, or we can zoom in and zoom out by using your mouse or trackpad, and we can see the bonds, the atoms, and we can see some other details as well. I'll try to see, for example, to zoom in here, and we can play the trajectory to see the details at that particular location, for example, and we can highlight the bonds or atoms also. Now I will stop it and let me go to the beginning of the trajectory and to the almost full screen. Okay, this is the player that we see. Now let's go to the bottom of the page. And in the bottom of the page, you will see your initial PDB file basically and target PDB file. And in the results section, results files section, you will see an output txt, a transition structure CIF file in CIF format, and you will see a coarse-grained movie of your trajectory. You can download it and you can play it in your favorite molecule viewer, such as Chimera or Pymol or any other movie, or VMD maybe. Okay, your results will be available on the server for 15 days as long as you save this job ID or you save this address. They will be available for 15 days. The entire Zika virus modeling took about 40 minutes, so including the loading of the visualizations and the calculations. Considering this big size of this system, which is about 70,000 coarse-grained atom, this is a quite good, a quite fast computation time.